Unit 4, Section 11.3 Worked Examples. Use the following statement to answer parts A and B. 100 raffle tickets are sold for $3 each. One prize of $200 is to be awarded. Winners do not have their ticket costs of $3 refunded to them. Raul purchases one ticket. Determine his expected value. Determine the fair price of a ticket. Determine the expected value. There are two outcomes. You win $200 or you lose. If you win, your gain is $200 minus $3, the cost of the ticket, or $197. The probability of winning is 1 out of 100, since 100 tickets are sold. If you lose $3. The probability of losing is 99 over 100. We set up the expectation using the expectation formula, the probability of each outcome times the amount of each outcome. And I'm going to pull my calculator up and go ahead and simplify each part there. So the first part I've got is 197 divided by 100, which gives me $1.97. And the second part is actually going to be a negative because it's the loss of the $3 when I don't win. I lose $3, so I've got 99 divided by 100, and I'm going to multiply that times the negative $3, so I actually lose $2.97. And if I add those two numbers together, I get an expected value of negative $1. Now, what's the fair ticket price? The fair ticket price is the expected value plus the price to play. The expected value that we found was negative $1. The price to play was $3. So the fair ticket price is going to be $2. For an outdoor concert by the city orchestra, concert organizers estimate that 12,000 people will attend if it is not raining. If it is raining, concert organizers estimate 7,000 people will attend. On the day of the concert, meteorologists predict a 90% chance of rain. Determine the expected number of people who will attend this concert. There are two outcomes, rain or no rain. If it rains, 7,000 people will attend, and the probability of rain is 0.9. If it does not rain, 12,000 people will attend. What is the probability it does not rain? So the probability of raining is 0.9, so the probability of not raining, therefore, the other outcome must be 0.1. And if I go ahead and put that into my expectation formula shown here, and in my calculator, let's go ahead and simplify those parts. So first I've got 0.9 times 7,000, the number of people that I expect if it's raining, 6,300. And then the number of people I expect if it's not raining is 0.1 times 12,000. Oh. 0.1 times 12 gives me 1,200. So 6,300 plus 1,200 is going to give me an expected number of concert attendees of 7,500. For the wheel pictured below, assume that a person spins the pointer and is awarded the amount shown by the pointer. If it costs $5 to play the game, determine the expectation of a person who plays the game and the fair ticket price to play the game. Determine the expectation. There are two outcomes. You win $4 or you win $10, and each has a probability of 0.5. If you win $4, your gain is actually negative $1 since it costs $5 to play. If you win $10, your gain is $5 since it costs $5 to play. So I set up the expectation formula, and let's go ahead and simplify this in our calculator. So the first part is 0.5 times $1, which is going to give me 50 cents. And then I've got 0.5, so half of $5, which is actually going to be $2.50. So my expectation is actually $3. I'm sorry, that's not correct. This is negative. So my expectation is actually $2. Remember, in the first case, if I land on the $4 portion of the wheel, my gain is actually negative $1. So the first part there should be negative 0.5. So the fair ticket price now is the expected value, which was $2, and the price to play the game, which was $5. So a fair ticket price for this game is actually $7. Don is considering bringing a lawsuit against the Dumont Company. His lawyer estimates there is a 70% chance Don will make $80,000, a 20% chance Don will break even, and a 10% chance they will lose the case and Don will have to pay $20,000 in legal fees. Estimate Don's expected gain or loss if he proceeds with the lawsuit. There are three outcomes: make $80,000 with a probability of 0.7, break even, make no money, probability 0.2, and pay $20,000 in legal fees, probability of 0.1. And notice that $20,000 is a negative in the expectation formula since we're going to have to pay that if we lose the case. So let's get our calculator and simplify. So the first thing we have is 0.7 times 80,000, which gives us 56,000. And then we have a 0, break even. And then we're going to have a negative, and it's going to be 10% of $20,000 or $2,000. So my expectation is going to be 56,000. The 56,000 I still have in my calculator, subtract the 2,000. And so Don's expectation in the long run is $54,000, and that is a gain. So it appears that it would be a good idea for him to proceed with his lawsuit, since that is a gain. So $54,000 gain.